Hey, today we're going to finish our discussion on Chapter 14, Probability Rules, and just start with a comment on the terms independent and disjoint. Remember, disjoint also means mutually exclusive. Those are two things that can't happen at the same time. And independent are two events whose probabilities are not affected by one of the events happening. And so it's important to note that two events can be independent or disjoint. Okay, they cannot be both. All right, so if two events are independent, they are not disjoint for sure. If two events are disjoint, then they are for sure not independent. However, it is possible for them to be neither. That means they're not independent. One event happening affects the probability of the other event happening, and also there's disjoint or not disjoint, which means they both can happen at the same time. So that's just sort of a note to point out, to keep in mind as we go through probability. So we've talked about the multiplication rule. The multiplication rule when uh, two things are independent, two events are independent, we can just multiply probabilities together. But this is the general rule, the general multiplication rule. We can use for independent events and we can use for events that are not independent. And it just says you multiply the probability of event A by the conditional probability of event B, meaning the probability that B happens given A has already happened. And so recall that if two events are independent, then the probability of B happening given A happened is just the same as the probability of B. So when A and B are independent, this side just turns into probability of B, and we've kind of already used that. So I want you to take a minute and read this setup. No need to copy it down. It's from the book. Just read it, and then we'll move forward. So we have these batteries, some rechargeable, some regular, and we know that 2% of the regular batteries are defective, 1% of the rechargeable batteries are defective. And 25% of the batteries this company makes are rechargeable, meaning that 75% are regular. And so we want to answer these two questions. The probability a random battery is defective, and the probability you get a regular battery and it's not defective. So let's define some terms. Let's use R for rechargeable, B for regular battery, and D for defective. So the probability that we have a rechargeable battery and it's defective, and I'm pretty sure I was supposed to say here a defective rechargeable battery. So the probability that it's defective and rechargeable is the probability it's rechargeable times the probability it's defective given that it's a rechargeable battery. These two things are not independent of each other. The probability that the battery is defective changes based on whether or not it's rechargeable or it's a regular battery. They're both not the same. One is 1%, one is 2%. So the probability of being rechargeable is 0.25. Probability of being defective if it's a rechargeable battery is 0.01. We were just given that conditional probability. So we find out the probability of selecting a rechargeable battery that's defective is 0.00 excuse me, 25. So not a very high percentage at all. And we want to figure out the probability of selecting a regular battery and it's not defective. So we're doing a and probability, regular battery B, and then the complement of being defective would be all the batteries that work properly. So again, these are not independent events. The fact that it is a regular battery means that the probability of it being working is different than if it was a rechargeable battery. So 75% are regular. And since 0.02% of our regular batteries are defective, that means the complement is 1 minus that. And so 0.98 is the probability that the battery works. And when we multiply, we get 0.735. So we have done some probability where we have selected candies or we've selected uh, other things like that from a bag or a box, and we've assumed that we're going to put that thing back in there before we selected another one. Well, sometimes we don't replace the item we selected, and that is going to affect the probability of the next item we select. So go ahead and read this scenario. Again, don't copy it down. It's from the book. So we have a bag of Skittles with this distribution of colors, and uh, we want to take one Skittle out at a time without choosing the color. That's why we only tear off the corner. And so we want to know the probability that our first two Skittles are both orange and the probability that none of our first three candies are green. So let's do part A first. There are 5 orange candies out of 20. We'll let O mean orange. So we're looking for the probability of an orange and an orange. Since we are taking a candy out and not putting it back, we're going to change the probability of getting an orange the next time because there are less candies and there are less orange candies. So we need to use the probability of orange times the probability of getting orange given that the first candy was orange. So the probability of getting an orange candy the first time is 5 out of 20. There are 20 candies, 5 orange candies. If we have to assume that the first one we take out is orange to complete this probability problem, and so that means there's only 4 orange candies left and 19 total candies left. And when we multiply the tops, we get 20, the bottoms we get 380, and we end up with 0.0526 probability of getting an orange on our first 2 Skittles. So not a terribly likely scenario. The next one, we want to know the probability of getting 3 candies that are not green on our first 3. So we're going to say G is green. We want to know the probability of the complement of G happening 3 times. And so there are 13 candies that are not green out of 20. When we take one out that's green, we have 12 green left out of 19 total. And then the third time we only had 11 green left out of 18 total. So when we multiply all these 3 fractions together, we get 0.2509. So approximately a 25% chance our first 3 candies out of the bag are not green. And we're going to work on some of these problems together in class before you are off on your own, so don't worry about being a pro just yet. One thing that we can do when we're working with probability problems that help us, we've already made Venn diagrams, and that helped us when we had events that were not disjoint. They had 2 events that could happen at the same time. Another thing is we can draw a tree diagram. So we're back to the battery scenario, same numbers, 25% rechargeable, 75% regular, 2% regular batteries are defective, 1% rechargeable batteries are defective. And so we want to find the probability that if we randomly choose a battery from a shipment, that it is defective. And so what we can do is we can build a tree. And so we start with all of our batteries here, and then we split them up into regular and rechargeable. 0.75 regular, 0.25 rechargeable. And then within each of those groups, we have some batteries that are defective and some that are okay, some that work. For regular, 0.02 or 2% are defective. That means 98% of them are okay. For rechargeable, 1% are defective, 99% of them are okay. So what these probabilities on the right are and probabilities. So this 0.015 is the probability of a randomly selected battery being a regular battery that is defective. We just multiply these two things together. This 0.735 is the probability of being a regular battery that works. We multiply them together. These two things are conditional probabilities based on it being a regular battery. Similarly, we have a 0.0025 probability of getting a rechargeable defective battery and a 0.2475 probability of getting a rechargeable OK battery. So the probability of one of our batteries being defective is going to be the probability of being a regular defective battery or being a rechargeable defective battery. And since you can't be a regular defective and a rechargeable defective at the same time, these two things are disjoint, and so we can just add their probabilities together. So we are going to add this probability together with this probability, and we are going to get a total probability of 0.0175. So just under a 2% chance that we draw a battery at random that is a defective battery. So that was kind of a lot on a small amount of pages. So we'll do some together in class, and then of course you'll have plenty of practice and time to answer questions.